Hey everybody, how you doing today? Hope you're doing alright this wonderful Tuesday here. Look at that, perfect. Oh, okay, almost perfect. Should have muted it a little sooner here. So, we've got a couple things on tap today. Hopefully you got a chance to finish your Lab 1. I know I heard from at least one of you having some trouble. We didn't get a chance to meet up yet. So, for this one, that's fine. I'll meet with you. We'll make it work. But again, generally, don't take those ones late. But this was just our getting started, setting up our tools sort of thing. The Syllabus Quiz and Chapter 1 quiz due by the end of today. So 11:59 p.m. for those. Should be pretty straightforward. If you get marked wrong on one of these Chapter 1 quiz questions, some of like the fill-in-the-blank style questions, if you add an S or have a period somewhere where I was unexpecting it, it'll mark it wrong. Just shoot me an email. Let me know which question it was, and I'll go correct it for you. I just generally don't look at all of them, if that's okay to say. So if it's wrong, you let me know, and I'll get it fixed for you. I'm not going to go and check all of them beforehand, or without you letting me know. So. On tap for today, we've got Chapter 2, writing your first Java application, and then your first big project. And we'll still have a lab for Chapter 2. It'll be short and sweet. Again, the idea of this course is it's a lab-based course, so I'll try and spend about half or so of the class showing you stuff, and then I'll turn you over to a lab assignment, and you've got the second half to actually try that out, hopefully get that done within that course time. I can hop around and do screen sharing or whatever we need to do. Just shoot me an email so I have your actual name and the question number, and I can go take a look at those, no problem. So it's a little flaky with some of those fill in the blanks, but overall I think they're generally fine, and hopefully are encouraging you to actually open up the textbook. So we'll cover Chapter 2, we'll work on our lab, and then we've got the first Project 1 coming up, and we just pick a chapter a day. We keep on going. We don't bother with Chapter 6 because it's about debugging your application, and we're going to be doing that throughout as we work on these. So I don't think we need to spend a separate chapter on that. And then don't forget, our midterm is before midwinter recess, so that you can actually have a break. Everything will be done and in for the course. After the midterm's turned in, your Project 2's in, you got the midterm, and then you can actually take some time off, hopefully, to get a real break in, because it's a big bummer when we have not a chance to actually get a break, because that is important for sure. So, and then we'll pick it back up, and again, we don't touch most of Chapter 12, we just only this array list section of Chapter 12, so it's real short. File I/O we only do about half of, because we don't do the more complex file input and output operations. We save that for the next course if you do continue on into object-oriented programming with Java, CIS 2151. And then we touch on exceptions. We don't do a whole lot with them ourselves. We talk a little bit about handling here. We go a little deeper as well in Chapter 16, and you'll pick up more of that again in the next course as well. We'll intro the fourth project. I want to give you more time to start that final project if you're the kind of person who's going to work ahead. So I want to introduce it before April 4th so that you've got a whole month to work on. Yeah, so Chapter 2 is the topic for this week. So how to write your first Java applications is what we'll talk about. That comes from Chapter 2. We'll go through lots of examples, and then everything you need for Project 1 will be in Chapter 2, or Chapter 1 and 2. It's just like math class. You don't get to forget anything that you've learned beforehand. It just kind of all builds on itself. So it'll just keep on adding. So we're adding new tools and techniques and ways to solve problems, and then you get to go solve those problems yourself. Okay? All right, I'm about out of coffee here. This is pot number 2 of the day. Got one last little swig here, so bottoms up. There we go. And I'm out of Diet Coke, which is a real bummer, because that's my usual go-to if I'm out of coffee. But I guess I have to make a trip to the store. All right, so we fire up NetBeans, and we'll go from there. So while that's loading up real quick, just another reminder. I've got recordings here linked from D2L, but you can also just go find them on my YouTube channel. If you go out there and subscribe to that, you're welcome to find them there as well. So as we go through courses or classes, I'll just keep adding them to the archive here. You can always go back and look at them later if you like. I know some people are fond of YouTube because you can do the speed up or slow down, which was interesting when I everyone do their lab and introduce themselves and the syllabus tell me what time you're going to be watching class. Some people commented that they watch things in increased speed, and some people commented that they watch them slower so they can follow along better. So it's cool, hopefully, that it works out well for different people and different learning styles, and that goes well for you. So, all right, I'll put all those out there. And you got the textbook slides, again, if you're interested in following along with those. They don't give you everything in the book, though, so I definitely would encourage you to go out and get the book for additional reading. That's our main reference for the course. That's where our quizzes are coming out of. But my goal is to give you different examples so that you can see it my way, you can see it the book's way, you can try the lab, and then you can work on the big project as you get some chance to practice this stuff. So I'm a firm believer that the only way you get better at coding is by writing code, right? So, reading is fine and watching someone is fine, but you've got to go out and do it yourself. You've got to go out and try these things to make it work yourself. Okay? Let's see. Do we get NetBeans? There we go. Oh, almost there. Almost loaded. And then I have the course repository as well here in content. So all of the code examples I do in class will go here to the course repository that's linked. This is my public GitHub repository for the course. No, I didn't get a new computer yet. I was putting it off. Part of me wants to get a desktop, but then when I do take my laptop to classes, I won't have the nice new computer, and I'll still be on the slow one, and I'll be sad. But I know laptops don't last as long, and Oh, for sure. TAMNU, that's what we're doing. Yep. So we've got to learn some of the syntax today to help us start reading code. For sure. Yep. Chapter 1 is just a quick intro. Chapter 2, we kind of throw you in the deep end and then start hopefully pulling it apart and making sense of some of the code. And I kind of do like that's Marok's approach. He's like, hey, here's a program, and then let's go show you all these pieces and how it all worked. I think that's kind of fun. It's a different approach, but and there also is, I should remember this, there's a open educational resource, a prof out of HWS, and I used to know what that was called. I forget HWS. I don't remember if it says it somewhere. I forget. But he's got a free Java book that he wrote for his class. So you can just check out the website here if you want additional examples and things to follow through. So I'll post that if anyone's interested, and I'll post that in the Discord if I remind myself to do that. Post in Discord, Java book. Okay. Got a little note for myself there. All right, I know it looks real like old school web style, but it's nice and simple, and like you can click through and just see all sorts of examples, and he does all sorts of good stuff. So I'm fond of this one. So Mr. Eck has done a pretty nice job here. All right, the course repository here. So all we have is the Hello World example, right, from last week, but we'll be adding new examples. So when I go to NetBeans and I start a new project, let me close this one down. That was this morning. I'm going to go to New Project, go on Java with Ant, Java Application, and I'm going to pick my course repository. So for you folks, remember you're going to pick the lab repository or project repository that you're working on. For me, I'm going to put all the examples here in our public repository. So the repository is just a folder. So all you got to worry about is it's a folder. And we'll call this, how about week 2? If I name things by week, maybe that'll make it easier to follow along, I guess, because right now it's just Hello World, but that's okay. And it's going to start us off with some starter code. And now we actually get a chance to look at what some of this stuff means and what some of this stuff is when we look at it, which is kind of fun. We're starting to learn some of the syntax, some of the rules of how Java code is written so that the Java compiler can understand it. So again, this /* // that's a comment block. I'm just going to get rid of those for now. We can get more into comments in a minute, but I'm going to clean that up. Don't need any of those to start. And right in here, this first, just a // is where we're going to start. Everything's going to be inside of main, inside of this set of curly braces for now. And we'll just go from here. So if you want to check to make sure you got it in the right location, you can pull up your GitHub desktop client and check the repository. It should see a bunch of files were created because the NetBeans project gets created there. There'll be a bunch of NetBeans files and then a .java file, the one that we're working on. So we know we got it in the right spot. Let me find 1500 Tuesday. Here we go. Right, so I see my week 2, all these files here, the NB project files, those are all fine. Later down at the bottom, I see my week2.java. And again, it's not a whole lot in there right now, but that's great. So I can give it a commit if I want. Here's week 2 started. Commit will make a snapshot. It saves that point in time of what this folder looks like and the contents of it. I can push that out to the cloud, to the github.com origin or central repository. Once github.com has it, it's really, really hard to lose it. I don't want to say impossible, but really hard to lose it. So if I come back to the website and refresh, F5, not F4, there we go, I'll see week 2. And remember, just on the website, you can browse around and see the contents of any text-based file, which all of our Java applications are text-based files. It is just a bunch of text here. It just so happens that we're going to follow the rules so that the Java compiler can also understand it in addition to us people. Dark mode for GitHub desktop. So I think this one just picks my Windows theme, I feel like. I don't think there was an option. Was there an option for it? Oh, there is an option. Look at that. Oh yeah, matches the system theme, or you can just explicitly pick dark mode. Look at that. Yeah, I'm quite a fan of dark mode everywhere. I do not like to get by. I wish D2L had a dark mode because it is super bright, which is a little unfortunate. All right, so when we're dealing with our code, right, so far the only thing we looked at were these print line commands, and printing is just putting something, displaying it on the screen. You can type it all out if you want to. Again, I'm a fan of shortcuts, so instead of saying system.out.println parentheses quote, end parentheses semicolon, D2L is our course tool. Desire to learn. This is one where the syllabus was. This does not respect dark mode, and you're like, oh, my eyes. There's probably a plugin I could get, but maybe we'll figure that out later. So system.out.println with the parentheses and quotes and semicolon, sure. Or, right, again, if you are like any good developer, you're lazy, it's SOUT and hit tab. It's a shortcut in NetBeans. So each IDE or integrated development environment is going to have its own set of shortcuts. Everyone's just a little bit different. So it just depends on what you're working in. So Eclipse is another relatively popular one. I forget what their shortcut is. There's IntelliJ is pretty good. That's got its own set of shortcuts. So you can just Google them and find those sorts of things. So again, just if the tool can make it easier for us to get our work done, we're going to do that, right? We're going to take those shortcuts because that makes us more efficient. It's awesome. So the only thing we did then was we printed out some stuff. We said, hi there, you introduce yourself, that sort of thing. And that's great. And when you run your program, right click run or hit the play button up here for run, we'll see that output. But it doesn't do a whole lot for us. It's not solving any problems really other than displaying something to the screen. Oh my goodness, my plugins are the worst. So if you hit run and nothing happens, you might have the same problem I have sometimes. You go to your project properties, go to compiling, and uncheck this compile on save. It was working great earlier, so I don't know what I did to break it. Or if I can just fix that plugin. Let me check my plugin real quick, because that's going to be frustrating. I thought I had Java C. Didn't I have that one? I had that one. Java C. It's this one. User install plugins. It's there. It's just not. Okay. Whatever. It's just not working. That's obnoxious. So go to the properties, turn off that compile and save, and then when you actually run it, it should give you some good output. I don't. This one is cranky apparently. It worked fine this morning. That's the weird thing. And now I can see my hi there. This is what we really care about. So behind the scenes, right, all that fun stuff that happens is it actually compiles your Java class file or Java file into a class file. Right? So if we hover over the project here, it says it's in C users, Eric C, documents, GitHub, CIS 1500, all that good stuff. Yeah, I did have that same problem last week. That's right. It must just be the nighttime that doesn't like me. I'm going to go to repository, show in Explorer, or open in PowerShell is even nicer here in Windows land. In Mac land, I think it'll open in terminal. If you so cared to, we could do this stuff by hand that Java with Ant is taking care of for us here. Thought I have the latest PowerShell version. That's weird. That's fine. So I'm going to go to that folder here. So that's CIS 1500, winter 2022, on Tuesday, and then into my week 2 folder, and I've got my source folder. I can see that one inside of week 2. I can see this. Now there's a week2.java. All of that just to find this Java file. Then what I can do is I can use that Java, the JDK that we downloaded. Here, I'm just going to show you. We used to make people do this, and I don't think it's all that useful. It's fun to see, but that's it. So in OpenDev, right, where I unzipped my JDK folder, in the JDK directory, there's bin. So bin is where all the binaries are. These are all the executables, all the things that run. Inside of bin, you'll see there's a Java executable. This is the Java runtime Java virtual machine. There's also a Java C. Java C is for Java compile. So you can give Java C a Java file and it will compile it for you and build that class file, which is that Java bytecode that the Java virtual machine runs. So if you cared, right, we could go to OpenDev and we could go to the JDK. I'm using tab to autocomplete because typing all this stuff out is obnoxious. Java C, and we would give it the week2.java file, and it should compile it for us. Now I see I have a week2.class file. So Java C will compile to generate a class file here. Then I can run, so I can go to, I'm using up to get back to the previous command. I want the Java executable. And the Java executable, you can give a name of a file. Now you don't tell it .class, you just give it the name of the file. Oh, goodness. Oh, I'm in the wrong folder, right? So we've got that. Let me try this one more time. Let's do a Java file, week2 / week2. There we go. So because it's in a package, I have to run it from the package directory. Again, all this stuff we don't even care about because NetBeans just does the magic for us, which is amazing. So running Java files by hand are obnoxious, but sure, it worked, right? So we're able to compile it by hand using Java C, and then run it using the Java executable, opens up the Java virtual machine, reads the Java bytecode out of the class file, and the magic happens. Or just in NetBeans hit play. I'm much more a fan of hitting play. But you can do it by hand if you want, and I think that's the whole point here. And that looked real fancy, right? Getting familiar with the command line or PowerShell its terminal is definitely worth your time, but we don't really have enough time to get into that in this course. So definitely pays to be familiar with it. It's quite a handy tool. Okay, so you have hi there. Now, if the only thing we can do is print, we're pretty limited. So one of the things we can do with our Java programs is we can make Java store information. So while the program's running, we can tell Java, hey, I need a place to store numbers, I need a place to store characters, lots of different types of things that we want to store. So generally, we'll deal with 2 types of numbers. We have integers, which are whole numbers. So you'd say int, some number equals, and we can give it a number. So when you name variables, this is my name here. You get a pick as the programmer. This is a programmer assigned name or a variable name. You can name it anything you want, essentially. Very, very few rules around what you can't name it, but essentially anything that shows up like in orange here, this is a reserved word in Java, you can't use because it already means something to Java. But other than that, we can name it what we want. And we want to use nice, meaningful variable names here. Like my favorite number. And then what we typically do to name them is they always start with a lowercase letter, and then every next word gets an uppercase letter. That way you can kind of see, okay, here's the word, here's the word, here's the word. You can follow it along. This is called camel casing. Right? So it starts low, and then you get the humps in the middle. Every time you get the next word, you get another hump. Right? Follow that along. So you want the variable name to tell you what it's doing. So this one's my favorite number. Sure, we can do that sort of thing. And then I could print it out. I could say Eric's favorite number is, and then to take a number here and kind of smush it into the output here, I can just say plus, which is not addition. This is, you're going to take the two things and stick them together, and I'll say my favorite number. Now, again, I'm not going to type out most of these, so that's why if the variable names look long, don't worry. You type a couple letters, and it's going to suggest it for you. You kind of pull that to the side a little bit more if I can. There. My favorite number. Generally, you don't want your code to go off the side of the screen. It's generally considered bad form if someone has to scroll right and left to see your code. Mine's zoomed in a lot, or I'm using a relatively large font, so it shows up halfway decent here on the stream. So I don't worry about it too much, but generally I want it to show up on the same line. And Java could care less where you have line breaks. It does care if there are strings. So a string is just a bunch of text. We put it in quotes. Double quote signs here, not apostrophes, the full quotes. Notice for my integer here, it's just a number. There's no quotes because it's literally the number 42. And I can run this, and it's going to spit out Eric's favorite number is. And notice I have a space here. If there's no space there, when I try and smush that together, it would touch the colon, and it would just look ugly. So let's say Eric's favorite number is 42. That's what we'd expect to get. So you can store integers or whole numbers. They can be negative or positive, and you can go up from about negative 2 billion, some 2.1 billion, to positive 2.1 billion or so. And the reason why you can only store such a large number is of how stuff is stored in the computer. It's really cool. But if you open up the calculator tool in Windows, it's actually a really smart calculator. And it's really cool. You can go to programmer mode. It's my favorite mode in the calculator here. And we can go to binary mode, and you can go to this bit toggling keypad. Looks like nonsense, don't worry about it. So what's happening behind the scenes is everything is stored in the computer in ones and zeros. Lots of fun, because that's the only way we can store stuff. So when it's stored, it's either a 0 or a 1, and we just string a bunch of these things together here. Why are these coming up? I didn't have those. I wanted a new Word document. Did I not close them last time? I didn't close them last time. That's why. Let's try that again. How about a new Word document, please? Let's go Word. So if you just string enough zeros and ones together, you can make numbers. So our usual system, right, is base 10. You have, say, the hundreds place, hundreds, you have the tens place, and you have the ones place. Now, if you think back to math class, this is actually base 10. So each one of these is 10 to the powers. This is 10 to the 0, this is 10 to the 1, and this is 10 squared, and on and on and on. They keep getting bigger. 10 to the third is 1,000, 10 to the fourth is 10,000, on and on and on and on. So that's 1, 10, 100. Right? So this is the base 10 system. Binary is a base 2 system. So with binary, you get 2 to the 0, 2 to the 1, 2 to the 2, that's a 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. So in an 8-bit number here in binary, right, a single on or off is a bit. Here, you put 8 of those together to make a byte. A byte is 8 bits. This is 1s, this is 2s, this is 4s, this is 8s, this is 16s, 32s, 64s, and 128s. So if you have a 1 here, you're going to add 128. If you have a 0 here, you don't add anything. If you have a 1 here, you're going to add 32. A 0 here, a 1 here, a 0 here, a 1 here, and a 0 there. Right, we're going to take 128 plus 32 plus 8 plus 2. So that's 40, 128 plus 2 is 130. So 130 plus 40 is 170. So to write 170 in binary, it'd be 10, 10, 10, 10. Not all that interesting, I'm sorry. But the Windows calculator here in bit flipping mode, I can go do that same thing here. I can do this one's on, this one's on, this one's on, and this one's on. And I'll see my decimal number here, my base 10 system, is 170. So you can flip all these bits. All right, now the reason why our numbers in Java are integers max at 2 billion is you get 4 bytes here. So 4 bytes makes 32 individual bits. And one of them needs to be saved to tell you if the number is positive or negative. So I really get 31 bits that I can add up together to get my maximum number here. So if I click all these things on here, do lots of clicking, click, 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 click. There we go. 2.174 2,147,483,647 is the largest positive number and the smallest negative number we can get, because we need to save one of these bits. If it's on, it's negative. If it's off, it's positive. So in Java, integers can store up to 2 billion, which is pretty good. I mean, not perfect, and you can do some math with this, but turns out you can't even do the math where Microsoft just announced today they've entered into a purchase agreement to buy Activision Blizzard for $69 billion. So with single integers, not enough, which is kind of sad. But apparently they're going to pay a lot of money for that company. Is Call of Duty really worth it? I've never actually been a fan of Call of Duty. I do like the other games. I've played Overwatch, I've played World of Warcraft, I played StarCraft back then. So saving a single bit here is used to indicate if a number is positive or negative, because you can have negative numbers as integers or positive numbers as integers. So in order to store it, it gets 32 individual bits, or 4 bytes. A byte is 8 bits. You gotta have that much space to store these numbers. It does weird things, Lemon. It kind of screws things up. So if we say int max number, there's actually, you can say integer dot, there's a max value here already that you can use. And then you can say, so if you want to do arithmetic, we're getting a little bit ahead of ourselves, so that's okay. So here's our maximum value here, and let's just print out the max value. Max int is plus max number. And then if I add 1 to it, I'm going to take my max number. I'm going to change the value. So this equal sign here is not equals. What we get here with a single equal sign, we call this the assignment operator. Stuff works in Java from right to left. So the thing on the right is assigned to the thing on the left. So we've told Java, hey, I need a place to store an integer. I'm going to call it my favorite number here in my code. Please store the value 42 into some location. And the cool thing is, Java, through the Java virtual machine, will go ask the operating system, hey, operating system, I need a place to store an integer. I need 4 bytes of memory, please. And your operating system says, oh, sure, here, Java, here's 4 bytes of memory you can use. It's at this location. Sure. And then the Java writes it there. And anytime you use the name, it knows to go look up, essentially, this name now represents that location of where it's stored in memory. If I want to change the value, I already have an integer called max number. I don't need to tell Java it's another integer. You only have to, this is called declaring the type of a variable the first time you use it. Here on out, I can say, hey, now I want it to be max number plus 1. So let's change the value. Let's assign the value. Let's do the thing on the right gets assigned to the thing on the left. And then let's add 1. And let's give it a run. See what we get here. Takes us back to negative. Look at that. We added 1 more. We tried in Java. It's like, oh, sure, we'll go for it. And now we're at negative. Ooh, 248. Look at that. I guess you can't have negative 0. So, however that works out. Yeah, so you can get weird things happening if you go over those numbers. So you do have to be a little bit careful. This is weird. But it takes the thing on the right, assigns it to the value or variable on the left. Right, so that's integers. There's now numbers. If you need decimal places, we use something called a double. Double is the most common one that we're going to use here. So it's double here. This is a number with decimals. It equals, how about 7.7? We can store that. Excuse me. Now, integers can fit inside of a double. Right, so a double can be an integer. Right, that's okay. But an int can never store a double. So if I were to just say 7, Java would be fine with that. It doesn't have to have the decimal place. It's still going to keep track of it because it's going to ask the operating system for room to store a double. So it'll have storage for that decimal place. But we can't say, hey, 42.0 here. It's going to be upset with us, and it says incompatible types. Possible lossy conversion from double to int. It's telling you a double doesn't fit inside of an int. So if you kind of imagine it like a funnel, right? The larger things can't fit in the smaller locations, but the smaller ones can fit as you go up, if that makes any sense. So we'll do 7.7. There are other types that store numeric values with decimal places. Another common one is float. I don't like floats, and they bother me, just for one particular reason. So if you say, hey, I want to float, we'll call this a smaller number with decimals, and you said 7.7, it's going to yell at you. And this is why I hate floats. So again, possible lossy conversion from double to float. So floats are smaller than doubles. So doubles are like the largest type we can use for storing big numbers with decimal places. Floats are essentially half the size. So you get, I believe it's 7 decimal places with floats and 15 decimal places with doubles, if you want that number of decimal places. Like that's its maximum storage here. So to tell Java you want a float, you put the letter F after a number to tell it it's a float. And that's why I hate floats. That's the only reason, and I don't use them. For what we're doing, for our purposes, we don't really care if a float takes up 4 bytes of memory versus 8 bytes of memory, because our computer has billions of bytes of memory. Right? So a kilobyte is 1,000, essentially 1,000 bytes of memory. A megabyte is 1,000,000 bytes of memory, and a gigabyte is 1,000,000,000 bytes of memory, essentially. Sometimes it's 1024, but depends on how you measure it. So if our computer has gigabytes of memory, then saving 4 bytes, or even like if we had 10 of them, saving 40 bytes out of the billion that we have is not going to really do anything for us. So it's easier for us to use double. It's not better, it's easier. It's the lazy route because we don't really care. Now, that being said, when you get into bigger and bigger and better things, if you're doing something that has thousands or millions of doubles, and you could fit them as floats, yeah, 1,000,000 times that is a decent amount of memory saved, right? That's worthwhile. But at the scale we're doing for our course here, we're never going to need to bother with floats. It's not going to save us anything, and it's just more hassle than it's worth. So double is the easier number to use. That's why Call of Duty updates are so big. Maybe? I don't actually know much about game assets and game design, but yeah, that's. I know some games have problems with their updates. Wasn't it a Fallout 76? Was that the game that had like a 70 gig patch? Which you were essentially downloading the entire game again because they didn't know how to patch it or something like that. I feel like people were making fun of them a while ago. Yeah, some patching is insane. Excuse me. So doubles and floats, great. So integers for whole numbers, doubles for numbers with decimal places. Some other types you might run into. You can use a char, which is a single character. So a single character like E, and now this one you use apostrophes. You don't use double quotes. This is apostrophes. Apostrophe instead of quote. If you want more than one character, what you want is a string here. Now notice string is a capital S. So string is actually a class in Java. It's a type in Java. All these other ones that show up orange here are considered primitive types. It's a little bit different. It doesn't matter too much to us at this point what's different about it, but string here is lots of characters. And then I can fit in like Eric. A char can only be a single one. You can't do 2 letters here. It's going to yell at you. So you can only have a single letter at a time. Where a string is a string of characters, just a bunch of characters strung together. And then if I wanted to use any of these, right, I could say, here's lots of characters plus, and just smush this in here. So Eric, right, lots of characters is where I'm storing this string here in memory. It'll go get that out, and then smush in here. This is called string concatenation. It's not addition. Like max number plus 1 is addition. This is doing addition. A string plus a string it's concatenation, where you just put the 2 strings together. Now, my favorite number is a number, but Java is smart enough to say, oh, you're taking a string plus a number. You probably don't want to do addition here because you can't add text and numbers. That doesn't make any sense, so I'll just stick them together for you. Right? It's relatively smart when it comes to that here. So it's able to do some of that for us, which is nice. Okay, so we'll give that a run. So these ones here, these are not objects. So the class string here, this makes an object. if you want the technical terms for it. We're creating an instance of string called lots of characters. Lots of characters as an object. These primitive types are just declaring variables. So we're declaring it here, and we're assigning. You can also, if you want, and some people get really weird about this, they say you should declare all of your variables first, and then go give them values. So if we wanted to, we could up here say, hey, here's an int for number to guess, and we declare it without assigning it. That's perfectly fine. Then later on in our code, we can say, hey, number to guess is equal to, say, I don't know, how about 57. You can then give it a value. So this declares a variable. At this point, Java is going to go ask the operating system, hey, I need a place to store something. Then when we give it a value or instantiate it, is our technical term here, it goes and puts this value into memory and writes that value into memory so we can use it later. Instantiates the variable. Right? Actually makes it real. So we're just declaring it. Later on, then we can actually instantiate it, give it a value. That's perfectly fine. Most of the time, I'm just going to do both at the same time because it doesn't save me anything, really. Yeah, no problem. No, that's great. Okay, so we've got some numbers here. Again, we're not doing a whole lot of interesting stuff here because every time I run the program, it's doing the exact same thing. Right, over and over and over and over. It always does the exact same thing because I don't have any input from the user. Right, it's all values that I've put into my code. So every time I run it, I get the exact same thing. Not all that interesting, right? And we could make Java do some math, right? I can have an int for, how about a first number is 10, and an int for a second number is, I don't know, how about 17? And we can say an int result then is going to be, we'll take first number, how about plus the second number, minus my favorite number. Oh, I forgot to tell you, I wanted to show you, to make sure you get that type ahead stuff, where like as I type the first couple letters, I type, FIR and it suggests things, tab will autocomplete. But if it's not doing that for you, you go to Tools and Options, and you go to Editor, and you go to Code Completion, and you pick Java from the language dropdown. Checkbox 2 and 3 here. Auto pop-up on typing any Java identifier part and subword completion. You want both of those things checked to make sure you get all that type ahead stuff. So it's Tools, it's Options, it's Editor, it's Code Completion, it's the Java language in the drop-down boxes 2 and 3. Okay, that'll make your life a whole lot easier because you don't have to do all the typing. And you can use nice long variable names, and hey, we'll just print out math gave us, and I'll append in here or concatenate in here the result. Now you could actually do all of this arithmetic right in here if you wanted. No, that NetBeans should save that one, xFlynn. That's a good question. It should save that setting for the type ahead. Yeah, it's only that compile and save thing that gets super annoying and weird. And I'm not sure why it does what it does. So inside of your print commands, you could also just do arithmetic, right? We could say, I don't know, how about 42 times 27 is equal to, and we'll put a colon in there, plus, and we'll do 42 times 27. It's going to do that for us. We'll figure out that 42 times 27 is something, and then just smush it on right here. We should add our space so it looks a little prettier. Right, so you can do, these are arithmetic, or you call them expressions. It's doing something. So 42 times 27 is 1134. That sounds right. So our other math, we had 10 plus 17 minus 42. Right, my favorite number was 42. That sounds right. So that's 27 minus 42. Yeah, that's probably negative 15. I think Java's decent at math here. But again, we're always getting that same output. We're getting that exact same result every time. It's not dynamic, and that there's nothing the user can do running this program that's anything useful. Yep, so this part is a string because it's in quotes. So this is a string literal that's in our program. I just have this bunch of text here, and then it evaluates this expression, 42 times 27, and sticks it onto my string for me, concatenates it on. Or you could do the arithmetic, save it as a variable, and append it in here. And we got lots of options for it. Oh, how'd they come out? Nice.
It's not a ton, so you have to eat it.
Okay, thanks. We have some knish for dinner here, courtesy of former U of M president Mark Schlissel. So it's a tasty snack. It really is. But after reading about everything, my wife was like, we should make knishes. So that's what we did for dinner tonight. I shouldn't say we. She and the kids made them. Okay. So our expression gets evaluated, and then it will just smush it on right here. Now, we still haven't done anything useful for the user. So what we want to do now is look at how can we get the user to give us some values. Now, for now, it's going to look like magic, and that's okay. It's not too big of a deal for what we're going to do for this. So mostly you can follow along, and it'll make a little bit more sense later. Yeah, I'll walk. Like some of these, number to guess and things. This int number to guess, we're telling Java, hey, I need a place to store an integer. It's going to go find 4 bytes of memory thanks to the operating system. Yep. So to get input from the user, we're going to not reinvent the wheel here. There's all sorts of really cool things in the Java library or the Java API, all the things that Java knows how to do that are already solved for us. One of those things is getting input from the user. So to do that, we can say, hey, I want to use this class called scanner. So scanner is part of the Java library, and now we need to give it a name. The book likes calling it SC. I don't like calling it SC. I prefer calling it like keyboard, because we're going to get input from the keyboard here. Again, this is just a name. You can pick anything you want. It could be Apple. Java could care less about our variable names as long as they're not one of those reserved words. And there's a slide or a page in the textbook has like a block of the 80 reserved words in Java that you can't use. It's pretty good at telling you if you use the wrong one. But I'm going to call it keyboard instead of SC because I like that. And we're going to assign it the value of, we use a special thing called new, and we say scanner. And then in parentheses, it's capital S system.in. Looks like nonsense, don't worry about it. And then it still lights up in red. NetBeans says, uh-oh, you've got a problem here. And the error is it says it can't find or cannot find symbol. Cannot find symbol is when it doesn't recognize what this thing is. Well, the problem is, because the Java library is so large, it doesn't automatically give it to you right out of the gate. So we're going to click on the little light bulb here. Most of these options are really bad. This is NetBeans, hey, you have a problem, I think I can fix it for you. Sometimes it's really good. Most of the time they're really bad. So the ones that are really good here are these like add import for java.util.scanner. If I click on this, it actually types some code for me up at the top here. So above my public class week 2 here, it adds this line import java.util.scanner. This is telling Java, oh, thank you so much for the hydration reminder, that, we want to use the class called scanner from the Java API, from the Java library that's found in java.util. So there's all sorts of cool things in this util library or utility library that we can take advantage of, but we have to ask for it because we don't get it by default. These are still really hot. And now that red light, all those red highlights go away. So scanner, our name for it, again, SC is fine, but I prefer keyboard, equals a new scanner, in parentheses, given system.in. System.in is the standard input. So when we're running a text-based console application, that's when I type at the keyboard. You notice system.out, we've been using print line. System.out is the standard output. That's at the console, that's the screen right there. So we use system.in and system.out a lot. They're also built into the Java API. Java just knows how to do this stuff. It's amazing. And it doesn't matter if it's running on Mac, if it's running on Windows, if it's running on Linux, if it's running on your phone, all sorts of places it can do this. Although you're probably not going to look at the console input and output on your phone. Right? That's all done in a graphical user interface, some sort of app somewhere. But now we've got this thing called keyboard. Now we can actually get some values from the user here. So how about we say your first number here. Yep, so this is creating an object of type scanner. So we're telling Java, hey, I need a place to store a scanner. I'm going to call it keyboard, and then we're instantiating it. We're creating an instance of that object with this new keyword here, scanner, and we're giving it system in saying, hey, please use the standards input here. Now, all by itself, it doesn't tell the user to do anything. So we need to prompt them. We're going to say, hey, enter the first number to add. So we're going to do a system out print line. Then we're going to get their input. So we'll say, hey, okay, now here's an integer. I'm going to assign it the value of, and now I can use this keyboard object. I can say keyboard dot. And keyboard dot is going to give me all of the things that the scanner class knows how to do. There's a bunch of things here that it can do. We don't care about most of them. I mean, pretty much we're only ever going to use next line. That's my favorite one here. Now the problem is next line is incompatible. So we have to do a little bit more tricky stuff here. So it says incompatible types. String cannot be converted to int. So next line will always give you a string value, which is the characters. It's just giving you a bunch of text. Now the scanner class is smart, and we could ask it for an integer, but there's a problem with using next int and next double, like the book example gives you, in that it leaves the enter key around, which is really ugly. So I try and never use next int or next double if I can help it. So what we have to do here, this is a string input, we need to convert it. So to convert it, we can say integer dot parseint. And parseint takes a string here, this is my string input, and tries to parse it as an integer. And this is the integer class in the Java API. If you hand it a string, it can turn it into an integer, or it can try at least. So as long as you give it a valid integer, it can convert it here. This converts string input into an integer. Maybe we should put that down a line here, or maybe probably above it, right? I think above it makes more sense. So we're going to get their string input from keyboard next line and turn it into an integer for your first number. Looks like nonsense, don't worry, it'll make more sense as we work on it, as we get a little further in, but we can essentially copy paste this whenever we want. So parseint is trying to convert or read, parse is like a way to read a string and turn it into an integer. So keyboard.nextLine gives you back a string. So how about we do this one? How about we have a string for name? Here, let's say enter, please enter your name. And then we'll say string name is my keyboard.nextLine. Okay, so the keyboard next line will always give you a string value, a string of text, whatever was entered at the keyboard. So when we ask for something, it's just going to sit and wait for us to type something in and hit enter. It reads everything we typed and stores it as name. So then we can print out here, we can say, hi there, plus name. Right? And maybe plus, let's add an exclamation mark, because the computer is really excited to meet us here. And if you're missing stuff like another plus sign here, it's going to tell you, hey, it expected an ending parenthesis. That's not the most helpful error. What it actually needs is to take a string and another string, we have to concatenate them together. We're missing that operator. We're missing that plus sign to say, take this string, smush this string together with this string. If you just put two of them next to each other, hey, the name string and a question mark or an exclamation mark string, it doesn't work. Java doesn't read your mind. So you have to be very specific with your syntax here. So string, concatenate a string, concatenate another string. So keyboard next line always gives you the string of text. So getting that string of text, when I said, hey, enter a number, we need to turn it into an actual integer so we can do arithmetic with it. If we just have a string, like if I were to type in 42 and I stored it as text, you can't multiply, you can't add, you can't divide, right? It's not going to work for us. So we need it as an integer so we can do arithmetic. So integer.parseint, given some sort of string value, will turn it into an int for us. And then we'll ask them again. So enter the second number to add. Okay, and we'll do the same thing here with a second number. Your second number. Integer.parseint, please convert this thing I'm about to give you. And what am I giving you? I'm giving you the keyboard next line. Whatever I get back here, whatever string you've entered. And if you want, you can do this in multiple steps too. You could say, here's a string for, we'll call it input maybe. Here's the keyboard next line, like that. And then we can take the input, and we can hand the input variable to parseint. It's just a string. If you want to be silly, you can also have other numbers too. You can say int, I don't know, another number equals integer.parseint. And you can do it yourself. We can just literally give it the quote 42. So the string value can be a string we type in. It can be a variable that we've defined. It can be a variable that we get user input from, which is fun. So this integer parseint is just a way of converting for us. So I prefer to do it on one line because I feel like it's less typing. Some people prefer to do it on 2 lines. That's fine too. Doesn't really matter one way or the other. It'll still get the job done. So we've asked them, enter your name, hi their name, enter the first number, enter the second number, and then we can tell them, the result is, and then we'll take first number, or your first number, plus your second number. Right, let's see what we get. All right, so enter your name. I'm going to say Eric. It says, hi there, Eric, exclamation mark. It's excited to meet me. How about we do 10 plus 20, and I get 1020. Uh-oh. Well, that's not right. Well, what Java did is it said, okay, here's a string plus a number. You want to concatenate. Okay, result is, quote, the string 10. Here's a string plus another number. You want to concatenate. We'll add in the 20. It follows order of operations. So these addition have a lower precedence, right? It worked here when we did multiplication because multiplication has a higher order of precedence. So if you want to force that arithmetic to happen, we just give it a set of parentheses. Remember, please excuse my dear Aunt Sally, I think is what the cool kids say for PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. If you want it to happen, you put it in parentheses. Now we'll actually get the arithmetic first, then it'll get concatenated onto my string here. Let's try one more time. So we get Eric, we get 10, and we get 20. Now we get a result of 30. So notice when it's running here, and it's waiting for input, anytime you have that keyboard not next line, it just sits and waits. It says it's running, right? It shows, hey, it's running over here, this little bar here. It's just waiting. I can type anything I want here, and until I hit the enter key, it's going to sit and wait. So now here's my name. That's even longer than, what is it, John Jacob Jingleheimer Smith or something? First number to add. So now if you give it something that's not a number, like if I spell out the word 10 here, it's going to crash. You get a bunch of red text, you get this big ugly error, and it crashes. This is called a stack trace. Doesn't mean a whole lot right now, but essentially you read it from the bottom up. So these first two lines are kind of junk here, not a whole lot here. But this one says week2.week2.main, so week2.java, :55. That means line 55 is where it crashed. And it crashed at integer.parseint, and the number format exception here at the top says for input string 10. You can't convert the letters TEN into an integer. Ashika, which line has the command that declares the method for string and int? So we're just declaring the type that we want to use. So if you're doing user input, right, we said, hey, here's a string for name, assign it whatever we get back from the user input. Or up above, I could say, hey, here's a string for lots of characters. I'm going to assign it the value of Eric. And every time I run it, it will always be Eric. With the keyboard input here, using the scanner class, I can type in any name I want, and it will be dynamic based on whoever's running it. So it allows your program to do whatever the user inputs it. So if I were to just, adding numbers is not very interesting, but if you give this to my first grader and tell them, hey, the computer can do this math for you, you don't have to do the addition yourself, they would love it, right? So just adding two numbers together here is super cool because they don't know what a calculator is. Sure. Right, we've made our own calculator, right, for addition here. Not the most interesting thing, but we're starting here, right? So we can get different types of input. We can get string inputs, we can get integer inputs, and now if you wanted to have a double value, right, like, so let's do one that calculates someone's pay, right? So we'll figure out how much you should get paid throughout the week. So we'll ask them, we'll say, hey, please enter the number of hours you worked this week. Okay, and we'll have an int for hours worked. And you know what? Some people work like not full numbered hours, and you should definitely get paid for your partial time here. Definitely always get paid for your partial time. I believe up to the quarter hour is the actual law there, right? So we'll make sure that we get to the quarter of an hour. So if we're going to have decimal places, we need to use doubles. 55, yeah, it takes the keyboard next line, which is whatever they've typed in, hands it to this integer parseint to try and turn it into an integer, and then stores it as an integer named your first number. Yeah, so it's taking a string input, converting it to an integer, and saving it here. So three things are happening. It's kind of a busy line here. but it's all happening at once. So if we're going to enter the number of hours we worked this week, we need a double here because it might have a decimal place. So this will be hours worked, and that'll be, and you guessed it, double dot parse double. You guys are so smart, guessing double dot parse double, given the keyboard dot next line. Right, so if you give me a keyboard input here, I'm going to take whatever it is, try and turn it into a double. The Java library here in this double class knows how to take strings and turn it into doubles if they work. Right, if you actually give it valid input, it's going to work and not crash here. And I'll ask you, please enter your hourly pay rate, and it'll have a double for pay rate. Double dot parse double, given the keyboard dot next line. Okay, so I have a hours worked and I have a pay rate here. So we can say your gross pay is, and maybe even a dollar sign here, right, to make it look pretty. Concatenate in here, or just add in, right, hours worked times the pay rate. Okay, so now someone can calculate this. Let's see how much money we make here, or at least the gross pay. Not what you're getting in your check thanks to taxes and other things, but so Eric, we'll do 10 and 20. All right, now please enter the number of hours you work. So let's say we worked 12.5 hours, and we make, let's go nuts, how about $25.4 an hour? I don't know. That should work out to $317.50. Pretty sure that math is right. Let's go check it. Why not? Let's open up the calculator. Now this does not work well in programmer mode. So I'm going to go back to standard mode here and do 12.5 times 25.4. And look at that. Java can do math. Not too shabby. The computer knows how to do math. So keyboard.nextLine in our code says type something in. Whatever you type in, we're going to give it back to you, and it's always going to be as a string. So nextLine always gives you strings. So I can store their input as a string if I want, or I can store their name here, right? Anything they type in, I'm going to store. If it should be a numeric value and I want to do arithmetic with it, I need to convert it. So I have integer.parseint or I have double.parseDouble will convert whatever they just typed in as strings, as characters, into the actual numeric value so I can do arithmetic. So keyboard is just this thing that we made from the scanner class in the Java library. I called mine keyboard. The book calls it SC. You could call it Apple. Right? This is just a variable name that we're using. So to use it, you give it the name and you say .nextLine. We'll give you that line as a string. So you always are getting strings back. So we can calculate someone's pay here. Again, this is much more interesting now rather than, yeah, so next line is always a string input. The scanner class does have other ways of getting input, but again, I would strongly recommend you avoid them because they don't work well together. So if you use like the next double or next int, the next time you ask for a next line, it's just going to give you nothing because when it goes to read a string, an int or a double, but the enter key character stays on what's called the buffer, and it stays there because the enter key is not a numeric value, so it just sits there. So the next time you ask for next line, it says, "Oh, there's something to be read." It's the enter key. You get blank back, and it's awful. Yeah, so we're using different types. We've got ints, right, for our numbers. You can parse their inputs, or we have doubles. You can do double.parseDouble. There's float double. There's all sorts of other conversions and other types. We'll talk about some of the other types when we come back from break. But wanted to get something kind of working here, right? All right, so I've been going for about an hour, looks like here. I think we're due for a break. So when I put some music on, we'll take 10, and then we'll come back, pick it back up at about 7:15 or so, and we can look at more of this stuff out of Chapter 2. More just basics examples, going through making variables, which is just a way to store information in our program, and things we can do with it. There's got more arithmetic to talk about, other operators. Again, this is the assignment operator. It's not an equals sign. We're not saying does this thing equal this thing. That's going to be a whole separate thing later, okay? So let me put the music back on, and we'll go from there. So we got break time. Go till about 7:15 or so, okay? See you back there in a second. Alrighty, folks. Welcome on back. Oh, nice. Just ending that one, too. I like this track. Alrighty. Yeah, Tam, for sure. So, specifically, objects are just these ones with the capital letters. So this declares and instantiates scanner object. Yep, the other ones are just variables. So these are primitive types, are just our variables here. You can declare the variable and then instantiate it if you want, or you can declare and instantiate all in one line. Either way is up to you. Yep. Does that help at all for that? So I've been doing these single comments here. So a single line comment, the // you can also do the multi-line comments, the ones that I took out before. I'm not a big fan of the multi-line comments. There's some good uses for them, but /* and then //. And NetBeans is smart enough to actually add it for you here. This is a multi-line comment. You probably did something wrong. You don't need multiple lines most of the time for any decent comment here. I've taken generally what's a pretty normal view in the industry that if you're including comments, your code's probably not clear enough. And that some people go nuts when they say, hey, every time you make a variable, you should have a comment telling you what the variable is. Like this stores my first initial. Like if you have to leave a comment to tell me what your variable is, your variable name is bad. In that your variable name can then say that when it says, so instead of single character, it could say like my first initial. Right? The name of the variable should tell you what it's being used for, not a comment here. Like that. That's okay. I wouldn't worry much about the lingo, Tam. It doesn't make much of a difference at all to us at this point, one way or the other. So you always give it the type here, and then your name for it. That's the declaring part. We're telling Java, hey, I want one of these things. I'm going to call it this. And it works with everything, whether or not it's an object or just a variable or a primitive type. So I want one of these things, a string, I'm going to call it this. I want one of these things, I'm going to call it this. That's the same everywhere. And what goes on the other side of the equal sign, assigning it here, we go do that. What's wrong with the float line? I just hate floats because you have to put an F here. That's literally the entire reason I hate them. It's one extra thing you have to type. And for all of our purposes, we're not doing anything at the scale at which it should matter. Right? We could have thousands and thousands of doubles instead of floats, and it won't impact our memory use barely at all. So we're kind of spoiled in that fact, right? Because we have billions of bytes of memory when you have gigabytes of memory. So we could care less if you're saving 4. Right? Not a big deal for us. So if you don't have the F, the error says incompatible types, possible lossy conversion from double to float. Because in Java, if you type a number at the decimal place, it assumes it's a double. If you really want it to be a float, you have to tell it F for float. Yep. So far, everything has been done inside of this code that already got written for us. Public class, and the name of the class matches the Java file. So if you open up your package here and you see, hey, here's week2.java, the name of the class matches letter for letter, case for case, the name of the Java file. It has to match. That's a Java rule. You notice there's no spaces. You don't ever want to use spaces in your Java files. So spaces are bad. And you can't put a space here. It just won't work. It won't do anything. The whole thing goes red. Right? It's real upset with spaces. And then inside of that class, everything we're doing is going inside of this public static void main string square braces args curly brace. Again, we'll figure out more about that later, but everything goes inside of that for now. Okay. We've done ints, we've done doubles. Great. Now the other thing you can do if you want, right, you can say, here's a bunch of variables, variable names, assign it to another variable. Right? You don't have to have any actual values literally in the code. They can all be based off of variables. And that's where the real power is, that these things can change, right? My pay rate, I could calculate gross pay if I wanted. I could have a double for gross pay is my hours worked times the pay rate. That's perfectly fine. And then I could do that instead of the arithmetic here. Right? I could just use gross pay. It doesn't really matter one way or the other. You can do the arithmetic here, or you can have a variable for it. Generally, a good rule of thumb is if you're doing the arithmetic more than once, you should save it as a variable. You only want to make it do the arithmetic one time. That's more efficient. And you're less likely to typo. Sometimes, it's not as common you'll do plus instead of multiplication, but it's possible you do plus instead of multiplication, right? Maybe you just typed the wrong symbol. That sort of thing can happen. Not too big of a deal. So we got all of our arithmetic. Let's see. Got names, numbers, yep. There's a shortcut operator here. So a lot of times what we'll do, like when we did this number equals max number, or max number equals max number plus 1, if you're just going to add or subtract something, we've got some shortcuts here. So if I wanted to give you a pay raise, good news, you get a raise, we'll say $1 an hour raise. If I'm going to take your pay rate, so two ways to do it. You can take pay rate and you can assign it the value of pay rate plus 1, which everything on the right happens before you assign. So pay rate plus 1 happens, then it assigns it to pay rate. So it takes the existing pay rate, adds the dollar, replaces the value here. Now that's a lot of typing, and it's even saying, oh no, that's not a helpful hint here. The shorter way of doing this, you could say plus equals 1. So plus equals is the shorthand for pay rate equals pay rate plus 1. If you're just going to replace the value, assign it back on top, you can use this called a combined assignment operator. We'll do the arithmetic and then assign it back. Now you do have to be careful because this is wildly different than from pay rate equals plus 1. So this is really bad. You don't want to do this because what's happening here is you now have positive 1 being assigned to pay rate. You just gave yourself below minimum wage, $1 an hour. That's awful. You've done a really bad thing here, right? You don't want to set pay rate to 1. So you have to be careful. It's operator, then assignment here. And you can do that for any arithmetic. You can do plus equals, you can do minus equals, you can do multiplication equals, you can do divided equals. Some fun things in Java land here. To do division. Division is fun in Java. So if I ask you to enter some more numbers here, let's just take our first number and second number. We'll say your first number divided by the second is, and then we'll add in here first number. Is it your first number divided by your second number? Right? These are integer values. Right? We've got your second number, your first number. So if we want to divide those out here, let's see what we get. How about, okay, name is Eric. Let's do 5 and 10. We had the results are 15. How many hours we worked? Let's do 10 and 20. Sure. Now we had 5 and 10. So 5 divided by 10 is 0. That's not exactly what we were hoping for. So when you take an integer divided by an integer, you get an integer result. So integer divided by integer equals integer result. Means no remainder. Right? So think back to your 3rd grade math, right? Long division where you have remainders. There is no remainder. All you get is that integer result. So if you have 10 divided by 3, you get, okay, 3, 6, 9, remainder 1. There is no remainder, so your answer is 3. So with integer division, you're losing any decimal place, you're losing any remainder here. It's a little bit unfortunate. You have to be careful. If you want a result with decimal places, you need one or the other, or both, of those values to be doubles. So if you want a decimal result, you need at least one operand. Let me bump this down a line. So if I'm inside a string and I bump it down a line, notice it ends the string and it adds the concatenation for me here to be a double. So right now my first number and my second number are integers. So what I can do instead is I can say, let's do this one again here. Don't want that. We haven't got to that yet. Quote. Okay. We don't need quotes here. My goodness, what happened? Okay, that was a bad copy paste. Sorry. So your first number divided by the second number. Second out integer division. And we bump that down a line, I guess. Sure. We can bump all this down. So until it hits a semicolon, Java could care less about the white space. The white spaces, the new lines here, are really just for people, because we expect people to read our code. It just happens to fit the Java syntax so the Java compiler can run it. I want to add another line here. So if we want it to be not integer division, one or both of these needs to be a double. Well, to do that, you can tell Java, hey, I want this thing to be a double. You say double in parentheses before the value. This is called casting. This casts a value as the type in parentheses. Parentheses? Parentheses? These? I don't remember. One way or the other. So it's going to treat this one as a double. It's going to say, hey, pretend this thing's a double. Then do the arithmetic. And now we'll get our actual answer out here, because one or both is a double. So enter your name, it's Eric. Okay, it is IS. Thanks, Tim. I'll do 10 and we'll do 20. We work 20 hours, we make 20 hours a week. Right, we get an hour pay raise. Great, division is fun. First number divided by the second 0. Uh-oh. Found a decimal, you need at least one operand. Here's first divided by the second without integer division is 0.05. So if one or both of those operands are doubles, we get a double result. So integer division only happens if you take one integer divided by another. So we'll say integer division in Java is fun. Right? And we'll say this is as an integer. And we just bump that down the line, I guess. Sure. Parentheses. Parentheses. This is what that double line does here. It will cast it to a parentheses. The other option you have is when you ask for their input, you can just store it as a double. We could say, hey, when I had int your first number, we could really say, hey, this is a double your first number. And Java's okay. You can say this is still an integer, stored as a double, because an integer fits inside of a double. Right? A double is big enough to fit that, where an integer is not big enough to fit a double. So a double takes up 8 bytes of memory. And there's a couple other types in Java you can look at as well, which are kind of fun. Dealing with text input. So we should say fun. If I want to put fun in quotes to be, my air quote fun, if I try and put quotes in here, it's going to yell at me. So what you have to do is you have to tell Java that this is a special character. So to do that, it's called an escape sequence. Don't bother memorizing it, just know you can go look it up. If you put \quote, the \/ character is telling Java, hey, I'm about to do something special. Because we rarely ever put backslashes in text. Right? I can't remember the last time I had a backslash in my text. So the \/ tells Java, hey, the next thing that comes after me is special. Treat it different. So \quote gives you the actual quote mark in your output. You can do other fun things. You can do a \n gives you a new line. We'll actually take your text down a line if you want. \r is similar. That's the return character, technically different than the new line. A \t for tab. Or if you actually want a \, you need to put in \\. Right? Divided. Right? \/ says, hey, something special. Oh, really? I did want a \ here. It's kind of silly. But you can do those. So those are escape sequences. So you can put those into your text if you want here, which is fun. Some packages. Yep, great. We did scanner. How to create objects. Yeah, we did that one. Did our methods for our conversion. Yeah, we've used print line. So some of those are useful if you're only using print. So instead of print line, there's also a print command. So this is using the system.out.print command, When you run print, it doesn't give you a new line. I've got 2 backslashes here for fun. So this starts the quote, this ends the quote around fun. So fun will have a quote to start and a quote to end. So it's backslash quote, backslash quote. These quotes here start and end the string in my program. You use print, then it won't be down a line. So like backslash quote here and backslash quote here. So the backslash only affects the very next character. This one here at the end of the string, the beginning of the string, like there's no backslash near them, so they're treated like regular quotes, which can start or end a string in Java. So this is called an escape sequence or character. Okay, that's the backslash. Is the escape sequence or character. Backslash. Okay, so if I just say print, I don't get any new lines, and all of this is just going to run together and look really ugly. So I'm not a fan of print. I almost never use print here. So Eric and 10 and 20, sure, and 20 and 20. So this is using system.out.print command. The next line, there is no new line here. It just ends right there and waits for the next thing to keep going. Where with print ln or print line, it prints your string and then goes down to the next line. So all of these ones here take me down to the next spot here. So the next time I print, it's on a new line here, which is, you know, that's part of the fun. And we can get rid of that class file too. I don't need that. Okay, so it's print versus print line. So some of those are fun, right? You can add in your own new lines if you wanted, right? We could then say, let's do another one here. Unless you add your own backslash n new line break. So backslash to get the actual backslash character. And how about I do backslash quote to put that in quotes. This is why I hate escape characters. They just look really ugly. So this will be quote backslash n end quote. Right, and we can put in our own new line here. Notice it bolds it for you. It's kind of nice to say, hey, this one's being escaped. So if we add in our own new line character, it'll do it for us. Let's see. So Eric add 10 and 20 and 20 and 20. Right, unless you add your own quote backslash n new line break. Notice this one doesn't have a new line, so this weird build success message is still just put after that line. Kind of funny. How do you concatenate a variable into a quote? So Java's smart enough to know if you're giving it numeric values with the plus sign, you're going to concatenate. So it takes a string. You can't take a string and add something to it. So it really is just going to concatenate. It's smart enough to try that for you. Okay. How are you folks feeling so far? All right, so the last little bit here in Chapter 2 is going to build on this and give us more tools. So far, all we can do is straight arithmetic, which is still powerful and it's useful to do arithmetic here. But we can't really do anything other than we always do this exact same thing. So one of the ways we get to do and make choices and kind of change what happens in our code here is by using some, they're called control statements. We can say, hey, if something is true, do this. If it's not true, do that. So we're able to, it's making a branch in our code so that something can happen if you want it to. And if it doesn't fit this condition, do something else. So they're really powerful. We need to use what are called relational operators here. So we can start using relational operators that give us a true or false result. Right, so if I say, hey, is your number greater than my number? Right, then we're going to compare them. How do they relate? Is yours greater than mine or not? So that's a true, yes it is, or false, no it's not. So we can ask for some values here, and we can check their relation to one another. So we can say, hey, if, now, so if is our keyword, and then you give a set of parentheses. And what you put inside the set of parentheses here, so it's a expression, a Boolean expression, goes inside the parentheses. Something that is true or false. Right, so what we're going to put in here, we can say, hey, if my first number, or your first number, if it equals my favorite number. Now notice this is a double equal sign. Oh, I messed that one up. So this one, no, your first number. There we go, your first number. We don't want that as a double. I'm sorry, I should change that. We want that as an int. Gotta leave that as an int. I guess you could call it a yes or no, but it's always going to be true or false, right? If you say yes is true, no is false, sure. But generally we consider it a Boolean, which is just true or false, on or off, yes or no. It's one or the other. So either this is true or it's not true, right? True or false. Then what we're going to do, so an if statement gets a set of curly braces. You should always use curly braces after your if statement. So anything that's inside this set of curly braces, if this is true, will happen. So I'm going to say, wow, that's my favorite number. So inside of here is an expression, something that will be true or false. Does this equal? You can say, hey, is it not equal? That's the exclamation point equal sign is not equals. If it doesn't equal, right, you can do that. You can do greater than, you can do less than, you can do less than or equal to, you can do greater than or equal to. All the same math operators, except you get double equal sign for equals. Because remember, the single equal sign is the assignment operator. This is assigning a value somewhere with a single equal sign. So the double equal sign is saying, hey, does it equal this value? Not change this, put this value, assign it over here. So single is an assignment, double is an equals. Right, so it is checking for equals. Okay, so if that's true, go for it. I can say, hey, that's my favorite number. Great. What I can also do then is I can say if it's not true. So I'll say, if this is true, do this, else, another set of curly braces. And either the if will run or the else will run. If it's true, it does this. Otherwise, else, it will do this other thing. So else's are optional. It is optional. You don't have to have an else. So we could, if we want, we can say, you don't, or I don't know, you didn't guess my number. Why not? You didn't guess my number. Either you know my favorite number or you didn't guess it. Sure. And these can be variables, or I can just put in here, like, hey, 42. It doesn't have to be a variable name. So I can either use variables or anything else here, right? I can compare it to whatever I want for some sort of statement there. Right? So I could say, hey, please enter your percentage score. And then I want probably, so if I ask you your percentage score, you're probably going to tell me like 95 or 97. You probably aren't going to use decimal places, so I'm going to use an int here for, how about percentage score is integer.parseint. So please give me an integer value out of the keyboard.next line. Whatever you type in, turn them into an integer and save it. Then what I'm going to do is I'm going to figure out what your letter grade is. So I can say, hey, if your percentage score is greater than or equal to 94, then I'm going to tell you, you got an A. Right? If it's not greater than or equal to 94, else. Now, we can start combining these things. We can make a chain of these statements. So I can have, if this is true, else if this one's true, else if this one's true. So I can say, else if your percentage score is greater than or equal to 90, you got an A minus. else if, right? So if this first if is true, none of this other stuff runs, right? So a chain of if, else if are mutually exclusive. Only one will run, right? As soon as we find an if that's true, the next else and everything after it doesn't happen. So I can say, hey, if it's greater than or equal to 94, great, you got the A. If it's not that, then it's going to check, is it greater than or equal to 90? Yeah, percentage score is right here. So we said, hey, I want an integer value for percentage score. Please assign it the value of whatever I get back from integer.parseint, keyboard next line. Grab the next line of text, turn it into an integer, store it as my integer called percentage score. Yep, we said, hey, I need a new value here, new variable. Yep, so if you're greater than or equal to 94, it's an A. If you're not greater than or equal to 94, if you're greater than or equal to 90, it's an A minus. If it's not greater than or equal to 90, else if your percentage score is greater than or equal to 87, oops, I need my curly braces here, you got a B plus, right? We're going to keep on working our way down. Yeah, so we said, hey, it's an integer for percentage score. Yep, we declared it right here. And we're just going to keep working our way down here. So I'm going to kind of copy paste that. So there's B, there's B minus, there's C plus, there's C minus, there's D plus, there's D, and then there's F. Okay. So then 83, I think was a B, or 84. It was 84, right? And then greater than 80 was a B minus, and then greater than 77 is a C plus, and greater than 74 is going to be a C, and greater than or equal to 70 is going to be a C minus, and then greater than 67 is going to be a D plus, and then greater than or equal to 64 I think was a D, and then I don't actually need another if here. I'm just going to leave it as an else. So if it's not any of those other ones, you got an F. So we used integer.parseint to take the keyboard input here and turn it into an integer. So you're going to enter, whoever's running my program is going to enter their score. We're going to take their input, convert it to an integer, and save it. So it's whatever they typed in, whatever the user typed in. We just ask them for a value here. Yep, so we're just going to go all the way down. So one and only one of these will run. The first one that's true, everything else gets skipped. If none of them are true, my last else here is the default. Yep, it's all based on user input. So you enter your score here, and I'll tell you what letter it is. Yep, and I'm going to give it a little format. That's a source and format, or Alt-Shift-F. It will auto-format your code for you. It's awesome. It'll automatically do all your tabs. It's fantastic. Yep. So we can use these if statements then, or else if to make a chain of them, to make sure one of them runs. One and only one runs. Yep. So if you're dealing with strings, the problem is we can't use this equal sign here for strings. It doesn't work the way we want it to. So if we want to compare strings, I can say, let's say, do you want to play? I don't know how. Do you want to play a game? And then I'll get a string for, we'll say, I don't know, user input is keyboard.nextLine. We'll just take that string. Now, if I want to say, hey, did they enter Y? I'm going to say user input dot equals. And there's two. There's equals and there's equals ignore case. Almost all the time we want to ignore the case because I don't care if it's an uppercase Y or a lowercase y. Users are bad at that sort of thing. Some users like to type in a capital letter, some people don't. So almost all the time I'm going to say equals ignore case Y. Here. So it doesn't matter if it's uppercase or lowercase, ignore case is going to ignore the case if it matches Y. we can't use for strings. I can't say, hey, if user input equals quote y. It just doesn't work. Lots of reasons behind the scenes that don't really matter right now. We can get more into that later when it's not the second week of class. So hey, if you want to play a game, great. Then we'll do this thing. We'll say, how about guess a number? Guess a number, 1 to 100. And I'll have an int for their guess. Will be an integer.parseint of the keyboard.next line. Okay, and if they didn't want to play a game, we'll say you are no fun. I don't know. So if they want to play a game, yes. If they entered a y, good. And so when we're prompting people, you should probably tell them like y/n, like to give them a hint, like enter a y or an n, please. Because otherwise, maybe they typed in the word yes. Yes does not equal y, right? So you got to be a little bit careful here. So I always suggest, telling them what you expect. Enter. Like this would guess a number 1 to 100. Hopefully we'll enter a number between 1 and 100 here. That sort of thing here. All right, the last thing we're going to look at here, and we'll get more into these as we go next chapter. We're just kind of teeing it off to show you all the different possibilities here. We can have a different kind of statement. So instead of if something's true, do something, we can say while something is true, keep on repeating. We can go over and over and over. So I can say, hey, while guess does not equal 42. You know what? I'm just going to, we'll just ask them to do it again. So I'll say, and now I already told Java there's an integer called guess. I don't need to tell it it's another integer. I can just say, hey, guess equals. And we'll say, that's not it. Guess a number between 1 and 100. And really, this is not ideal. It'd be nice to tell them too high or too low. Right? So why don't we do that? So instead of saying that's not it, we'll say, hey, if the guess is less than 42, oops, don't need that. We'll say too low. Guess again. Else if the guess is greater than 42, we'll say too high. Guess again. Right? And then we'll ask them to guess again. Right? If it's not 42, it keeps on going. So a while loop says, if this is true, run everything inside the curly braces. So if the expression is true, run everything in the curly braces. Once we get down here, go back to the while expression. So we're going to repeat. It says go back to the top. Once you hit this line, it says go back up here. If it's true, do it again. Once we get down here, we get to the end, go back to the top. If it's true, do it again. So we're saying as long as you haven't guessed the number, keep on guessing, keep on guessing, keep on guessing, keep on guessing. So this is a while it was going to repeat the code over and over and over and over and over again. So don't worry too much about that. Again, we're going to get further into that later, but it gets you some ideas of fun things you can do with that. And that's about it for today. And we'll get more into some of these details in the next chapters. So when we get into chapters 3 and 4, we'll have a lot more fun with these. And fun. I think this kind of thing is fun. It's gonna be a lot. But this control statements is all about ifs and whiles and those sort of loops and things. More in chapter 3, some primitive data types. More about working with them, doing some other manipulations, those sorts of things. If it's false, it doesn't run. So if the expression is true, it runs. If it's false, nothing happens. That's a good question. If the expression is false, it doesn't run. So it'll run until it becomes true, or I'm sorry, until it becomes false. So where guess does not equal 42, it means if you didn't guess it, we're true. So as soon as you did guess it, you're no longer incorrect, right? Not wrong means the loop stops. But so the loop runs while you're wrong, while you haven't guessed it right. So let's try it. Let's run it. So Eric and 10 and 20 and 20 and 20. All right, percentage score. What score should we get here? Oh, for sure, Snowden. Yep, I'll be committing all this. Yep. So what score should we get? Should we see if it gets us the right letter here? What do you think? Should we what score should we try and put in to see what letter grade we get back out? $88, you got it. So that should be a B+, right? All right, we got a B+. Do you want to play a game? Why or no? Yes or no? Yes, we want to play the game. All right, guess the number 1 to 100. All right, let's guess 85. Too high, guess again. How about 10? That's too low, guess again. 42. Stops. That's it. Right? As soon as this loop is done, that's it. Nothing else happens. That's the end of our code. How do you recognize that it's false and not an issue with your while statement? So that's a good question. So what you can do is you can run it in debug mode. I wanted to show you this next week, but I can show you it now. So at any line here, you can just click on the line number, and it's going to put a big red square there. That's a breakpoint. So what that's going to do is it's going to pause your program when it gets to that line, which is really cool. So instead of right-click run or clicking the play button, I want the play with line numbers here. This is debug. So debug is going to let us see the values of everything happening inside of our program while it's running. It's really cool. But it's not going to pause until it gets to that line. So I got to go back to the output tab and do all the things. So Eric and 10 and 20 and 20 and 20 and 95. Gonna play a game? Yes. Okay, now we get here. So now I hit that line, right? Java is waiting to run line 149. Wherever this green arrow is, that's the next line of code to be run. And you can look at the variables and see everything that's inside of it. Well, it should be down here, sorry. You can move these things around like anywhere you want. It's really crazy. It's super flexible. Usually I have it in a lower window. So right now these are all the variables that we've declared, and it'll tell you, hey, this is an int, this is an int, this is a double, that's a float, that's a char, that's a string. Here's the scanner, here's another string, here's an int, here's a double, right? All those things we've declared. All the values we can see in debug mode. So I'm about to say, okay, int guess. So now in the debug mode, we've got a stop, we've got a continue. These little arrow buttons are going to be the most useful ones. So we want the step over button. Step over says run that line of code. That's the most common one. Eventually we'll get to step into and step out of. For now, we don't really care. So pretty much everything's step over for a while here. So I want to step over that line of code. And it looks like it didn't do anything because it's waiting for keyboard input. I have to go back to my output tab here, and it's waiting for me to guess a number. So let's guess a number. Let's do 50. Now it comes back to debug mode and is waiting to run this line here. So now it says, while guess does not equal 42. Well, I can either hover over guess, and it tells me it's 50, or I can find guess in the list down here and see the value is 50. And then I can step. So 50 does not equal 42, right? If guess is less than 42, do something. That one didn't run. Is it greater than 42? Sure is. So step. Now I get to this line. It's going to run too high, guess again. I step. It printed that out in my output tab here. It says too high, guess again. Now it's going to wait for me to type something in. So I step. The green line goes away. It's waiting for that keyboard input. So I come back to output. Guess again. We'll guess 42. Now I'm back to this while loop, right? We got to the end. We went back to the while expression. Does guess not equal 42? Well, this is false because guess does equal 42. So that it stops, goes to the end, and we're done. Code's over. So debug mode lets you see inside of it. We'll spend more time with this next week, having some fun with that. So let's talk about our next lab here. Let me open up, set up the next lab link here. And then I'll add that assignment. So we are 1500. Let's do lab 2. CIS 1500, winter 2022, lab 2. Excuse me. We want to use the Java template. And we want these feedback pull requests. There we go. All right, so here's our link. Let's do lab 2. This is lab 2. So this will be due next week before class starts, 6 p.m. This will be 10 points worth of labs. Again, the points only matter in their category, so don't worry if something's worth 10 and something else isn't worth 10. It's just in the category. So please submit the feedback pull request URL. Lab 2. So we are going to do, let's do write a Java application that asks the user to play, ask the user if they want to play rock, paper, scissors. Have the computer always play rock. Compare the user input to the computer input to determine if they win, lose, or draw. And then ask if they want to play again and loop the whole program. Does that make sense? So we're going to say, hey, do you want to play rock, paper, scissors? Yes or no? If they say yes, then inside of that, the computer is always going to be rock. We'll ask them what they want to be, and we'll compare. Does it equal rock? Right? So let's look a little bit here at something. It's called pseudocode. It's like code, but not code. We're going to ask the user if they want to play rock, paper, scissors. So if yes, yes, inside of that, then computer is rock, and we'll ask the player for rock, paper, or scissors. Scissors. And compare if win, lose, or draw. And then we ask if they want to play again. So really this whole thing loops if want to play again. So really this one here could be like the, I don't know, call that the play again. It could be yes or no. Just while loop so far. You're welcome to use a do loop if you're familiar with it, but just the while loop so far. And we'll get into for loops later. So really this if yes is the same if they want to play again, right? This if they want to play, yes, right? Like why or no. So this loop, right? If they want to play, right, is the same why or no, yes or no. So if it's yes, computers rock, ask their guess here, win, lose, or draw, ask if they want to play again. That's the whole program. Right? This is pseudocode, it's like code, but it's English, right? It's just our way of thinking through it, kind of in, do I have the right steps? Because the hard part of programming, right, the real art of programming is breaking down a problem into step by step by step by step, simple enough that you can make the computer do it. So that's the goal here. So comparing win, lose, or draw, really we want to say, because we know the player or the computer is always rock, right? So winning then is if player is paper, right? Lose is if player is scissors. And the draw is if player is rock. So we don't even really need to do anything with the computer. We just know that they played rock, and we check, hey, if the player choice dot equals ignoring case paper, then they win. If it equals dot ignoring case scissors, then they lose. If it equals ignoring case rock, they tied. Hey, do you want to play again? Right, so then let me commit this code here. Here's week 2 examples. I see my week 2.java. There's all sorts of good stuff in here now, right? We did 178 lines of code or so. Not too shabby. Not too shabby. I'll push that out. And I'm going to link that for you too. So let me get that. Let me refresh. Here, we'll come on down. So that's the great thing about this. I can just link right in here. Actually, let me do this permalink is a little bit better because it's possible I could change this later. So C pseudocode in the example here. So this way it'll always link you right to that spot. And you're going to submit that URL. It's just a text submission. And life is good. So that's our practice of the lab. Using a loop, checking our string, does the string equal? That sort of thing. It looks like I had a couple more lab ones to finish. Thank you for getting those in. All right, so that's what we got for the rest of the night. Just trying to finish this one up, and then let's talk about the next project. So this, just a kind of a little practice of what we were doing. And then for the actual project assignment, this one's a little bit bigger, might take a little bit more time here. Let's do another one of these. Text submission here. This is project 1. And that'll be due in 2 weeks before class starts, 6 p.m. And this is, we'll say about 10 points here. And this will be in projects. Remember, the points only matter within the category in which they're done. So make a new repository for project 1. Right, so each project or each assignment gets done in its own folder. So just keep them separate. So this is CIS 1500, Winter 2022. This is project 1. We'll use our Java template. And feedback pull requests. Okay. Submit the feedback pull request URL. So you're going to write a helper program. I don't know, sure, a program that helps a user calculate, I don't know, not calculate, put together a shopping list to make knishes for their party. So we're going to make knishes for our party here. So the first thing we need to do is we need to ask them what type are we going to make, because we need to get different ingredients based on the different type here. So we'll ask the user what type of knish they want to make. You can make potato, potato, oh my goodness, I can't spell potato. Oh no, potato. Oh, this is sad. Potato? Oh, okay, there's no E. Why did I think there's an E? Potato, meat, or what's other types of knish? Let's see, what's another type? Oh, come on, tell me what like types are there. Oh, there we go. There is different fillings. That's the one I wanted. Different fillings. Chicken? Sure, we'll do a chicken. Why not? So you can make potato, we'll say beef or chicken. Okay, if they enter a value that isn't one of those, tell them you can't help them, and try again. End the program. Just let it end. There's other cool things we can do with loops we'll look at later, but for now, if they didn't enter potato, beef, or chicken, that can just be the end. Okay? So if they are making, and then ask them, how many people are coming to their party? Okay, because we need to know, based on how many people are coming to the party and what type they're making, how much we're going to need to buy. Okay? So for potato knish, you need to buy 1 pack of phyllo dough. Oh, no, it wasn't dough. What was it? Was it biscuit? I should look it up here. Let's look up the recipe again. What's the stuffing? What's the dough? we're not making our own dough. We just want a cheap one here. Let's look up a easy knish recipe. Easy potato knishes. Well, they only got 3 stars. That's not very good. How about the super easy ones? That one looks better. Puff pastry dough. Okay, that's what we need. Puff pastry dough. 1 pack of puff pastry dough for every 4 people. Okay, and this is rounded up. You don't want integer division to round down. You gotta make sure you round up. Okay. Oh, did we not get that other operator? There's one more operator I wanted to look at. I don't know if we went over it. That's a bummer. I'll show you that one next week. We don't need to, that we can wait. Round it up. Can wait until next week. Okay. So 1 pack of puff pastry for every 4 people, and you want 1 pound of potatoes for. Is there an E? My goodness. Oh, only if it's plural. That's why I thought there was an E there. 1 pound of potato for every 3 people. Okay. For beef knish, you need to buy 1 pack of puff pastry dough for every 4 people. Round it up. And 1 pound of ground beef for every, we'll say, 5 people. And for chicken knish, same for the puff pastry. So really this one's not different for any of those. Right? It can be the same calculation here. And 1 pound, I will say 1 pack of chicken for every 6 people. This is like, you're probably getting like a pack of chicken breast or something. Chicken breast for every 6 people. Okay, so calculate the required ingredients, and then again, still round it up, right? For all of these, we always want to round up. If you run out of food at your party, it's a big embarrassment. It's totally not cool. Big party faux pas. Right, so we're always going to round up to make sure we have at least enough to make what we need. It might be perfectly the amount, right? So with these ones that are 4 and 3, if I have 12 people coming to the party, right, there'd be 3 packs of puff pastry dough and 4 pounds of potatoes. Perfect. I would have no leftovers, right? Everyone would eat the same amount. If I'm doing this one here, if I had 20, right, they'll divide evenly. If I'm to have 24 or even 12 here, right, 12 people will still divide evenly here. So not crazy math here, right? And we'll talk about the rounding next week here, but we're going to ask them, and based on the different ones, we'll have different ingredients. We'll calculate the required ingredients and print out the required items to buy, right? Or required number of items, right? So if you are making potato knish, it'll tell you how many packs of puff pastry, how many pounds of potatoes. If you're making beef knish, how many packs of puff pastry and how many pounds of ground beef. If you're making chicken knish, how many packs of puff pastry and how many packs of chicken breast. Does that make sense? So again, all the things that we've done in here, right, we're not even going to bother with a loop, really. We don't even need to bother with the loop. We just want to use some of those if logics here. So we're going to, based on what they entered, grabbing their inputs, using those values, doing some arithmetic with those numbers, figuring out what they need to buy. Does that make sense? That's the next project for us. And I want to put together a rubric here for you so you know how you get your points. So let's do, these levels are silly. So let's just do, generally if it does what it's supposed to, you get points. If it doesn't, so if it's missing, there's no points. If it's complete, there's points. So let's do 2 points for this. So asks for what type of knish, potato, beef, or chicken. If they don't enter of the known types, tell them you can't help and to try again. Program ends. Yeah, explain, it's just a guess. So we're just average number of knishes here. So that's a good question, though. That is a good question. Right, so 4 points, right, for asking them and knowing the right type, and then you'll get points for correctly calculating the number of puff pastry packs to buy. I can't spell calculating. There's no points for spelling, by the way. Calculating. Why does it not fix it? It's saying fix it. It's not fixing it. That's fine. Calculating here, and then correctly, and this is rounds up, right? Rounds up, and then correctly calculates the number of potato, beef, or chicken required. And oh, I forgot. We need to ask them for their name. Ask them for their name. Use the name in the prompts because we want it to be a nice personal program here. So this will be the first thing here. Let me get that here. There we go. That's our 10 points for the rubric. 2 points each. So the first thing we do then, first ask their name and use the name they enter in all the following prompts. So we want to be a nice friendly program. Right? Oh, not save. Be a friendly program. Here. Why do I keep hitting save? No, not save. Okay? So like we did up here, we had said, hey, what's your name? And we said, hi there, name. We're going to use that name everywhere in the prompt. Right? So enter the name, enter the first number to add. We'd say, hey, name plus enter the first number to add. Right? So we're going to be personal here. We're going to pretend like we really care about the people here for all of our prompts. Ask them for their inputs, do the right arithmetic, spit out the right results. Does that sound okay? That make sense? All right, awesome. Let me save this one. So that's the first project we're going to work on, our little helper here. I didn't name the rubric. That's right, I got to name the rubric. So we got those two, the lab to work on. We should be able to get done before we walk out of class, and then we can work on the project this week and next. A little, less guidance is kind of the idea with these. A little more open-ended, like, hey, go do this thing, and I'm not going to walk you through it like I would with the lab. Right, you go do these things, and you get them done. That make sense? This overall score thing's obnoxious. This is like for English rubrics. Okay. There we go. So now we got the Project 1 rubric due in 2 weeks. We got the lab we're working on. That I think will take us through tonight and into next week. Nope. Snowden, as long as it gets the job done. So those points in the rubric are for if it does it. Any way you get it done is fantastic, right? Doesn't matter what it looks like. Yep, and feel free if you want to tweak it at all. I'm always open to expanding upon the idea, having a little bit more fun with it. But those are like the minimums we're hitting. So some people like to add in other things, or they want to add different flavors. If you want to make pickle knish, go for it. Right, that's fine. Just sub in one or the other. You can have a little bit of fun with it, if that makes sense. Okay, so that's all I got tonight for me talking at you. My plan is just to stop the stream and I'll hang around on Discord or check my emails. You can text me, whatever, message me, and we can hop on and do screen shares if needed. But the little rock, paper, scissors game should be pretty quick, ideally, right? Kind of follow through that pseudocode, look at getting the inputs, checking the loops, do my if checks, if, else, if kind of thing, and going from there. And then the project, again, a little bit more open-ended. I'm not giving you the leads, that pseudocode. This is, you're going to figure out those steps, that kind of thing. That make sense? All right, awesome. We'll go ahead and call it a day then. And let's see, is there anyone around? What day is it? It is Tuesday. Yeah. Let's see who's streaming for fun. Let me put on my ending screen here. Send off a Twitch raid just for fun. It's part of the fun of being on Twitch here. Let's see who's around on Twitch. Yeah, Tam, anytime you want to drop some comments in, go for it. And definitely, we've got the recordings available if you want to watch it again. But if something's not clear while we're talking about it, just pop in a message like you were doing. I'll drop in comments and happy to re-explain stuff for sure. All right. So I've got a friend here who does crafting, makers and crafting. He does a lot of working on a lathe kind of stuff, which is fun, CNC things. Or my friend Reluctant Hermit, who's just really silly and upbeat, really fun. I think we rated him last week. Either of those look like they're available. Someone else is doing woodcraft, doing some resin, or a friend who did a game design program and actually launched their own Steam game, which is pretty cool. We've got some fun people we could go raid. Or if you want to talk to a psych prof, we got an acquaintance who teaches psychology, and she streams on Twitch as well. Lots of fun stuff there. We got some good options. What sounds fun? You want to just do upbeat and silly? You want to do crafting? You want to do just games with our friend who does game design? Oh, thanks, Tam. That's awesome. Happy I can put that out there. Or a psychology. Any of those sound like they might be fun. Or paleontologist. If you want to go hang out with a paleontologist, you can also go right there. Got some fun options. Let's see. Oh, awesome. Let's see. If no one wants to pick, we'll raid Psych Queen. It's our friend and Psych Prof. We'll go hang out there, have some fun, and then I'll be back working on the assignments around on Twitch or on Discord. Send me a message, okay? Folks, take care. Have a great night. I'll see you around.